Okay, I want to do a couple problems out of section 2.3. I want to look at Venn diagrams and the shading because they can be a little tricky. So here's problem 5. You can see we have 3 sets, and this is how we draw them because we show that they're all intersecting. So let's do A first. And I'm going to focus on A intersect B, then I'll focus on A intersect C. I'm doing the parentheses first, then I'll worry about the union when I've got those. So because I can use different colors, I'm going to use that. So A intersects C, that is this. That's everything that's in A and in C. So in the blue is A intersect B. Now I'm going to do A intersect C. I'll use red. So I'm also going to shade this a different way, in a different direction, in case you only have one color. So in red is A intersect C. Now, when I do the union of these, that's the OR, I get everything. And if I circle that in green, that's everything I shaded. So that's A. Easier than a whiteboard. Well, we'll start with green. A union B, that's everything that's in A or both or in B. So there's A union B. Now I'm going to focus on the complement of C. That's everything that is not in C. So all the stuff out here in the universal set, that's not in C. Notice all this stuff in A is also still not in C. Okay, so red is the complement of C, everything that's not in C. Now I want the intersection of these two sets. Well, that's everything that's crosshatched. That's everything in here. You can see that has both red and green lines. That's the intersection. If I was to shade that, there. That's my answer. Okay, let's do part C. Okay, I'll do A intersect B first. Hopefully you see it's this by now. Now I'm going to union that with C, so I'm just going to do C in, oh, let's do orange. How about that orange? So now I have C, and the union of all this is just everything I shaded. It's all of this. It's C with this little kind of, I don't know, ear on it or whatever you want to call it. Just for the heck of it, what's this stuff right in the middle? That would have been A intersect B intersect C. The stuff that's in both of the sets. And if you do the associative property, it looks like this. You get the same thing. The intersection of all three, that just happens to be everything that's in the middle, as you probably expected. Okay, number 9, we're going backwards. Here's some shaded stuff. What does it represent? And yes, the answers vary. So I'm going to give the easiest ones. Here's stuff that's in B that's not in A. So this is the set difference of B and A. Okay, this is everything that's not in the union. So here's the union of A and B. So it's everything that's not in there. So that must be A union B, the complement. Notice the answers are hidden under here. Oops. There you go. Notice I have another answer as well. See if you can figure that one out as well using the complements of both sets and their intersection. Okay, this last one. There's different ways to do this. What I'm going to do is what pops out at me. What pops out at me is I see this. And I know that's A intersect B. But it's A intersect B, and I want to get rid of this part because that's not in it. Well, that's stuff that's in C. So if I take the set difference and take the stuff that's in the intersection of A and B, but not in C, I get this for my answer. Let's see what they saw. Hey, I got one of them right there. So practice some of those.